Hi, everyone. This is my journal club presentation. I'm Julia Williams, and this is on the efficacy of fecal microbiota transplantation, FMT, in patients with Parkinson's disease. So let's get started. So, jumping straight into our bottom line up front, let's talk about why this research matters. So, Parkinson's disease, or PD, is a chronic progressive neurological condition that is mainly seen in the elderly, and it affects 14 out of every 100,000 individuals globally. Currently, in the US alone, there are 1 million people suffering from Parkinson's. It affects 1% of the general population age 60 or above, and 2% of people over the age of 80. Now, Parkinson's disease is a disease that causes severe motor dysfunction, and this can be in the form of tremor, impaired balance, rigidity. It can also cause non motor symptoms, and some of the most common non motor symptoms are gastrointestinal disorders. And these disorders cause extreme discomfort to the individual, often requiring them to eventually hire a caregiver. So, um, these symptoms of Parkinson's just worsen over time, even with treatment by medication. So, finding an alternative solution that may improve the efficacy of these medications or symptoms like gastrointestinal disorders could significantly improve the daily life for these affected individuals. Fecal microbiota transplantation also has been shown to have the potential to improve the effectiveness of current medications against the clinical symptoms of Parkinson's. Now, some key findings for you guys to look forward to as I discuss this study is that FMT significantly improved the PD associated symptoms in patients. Gut microbiota composition in patients with PD differs from that of healthy people. FMT is safe and effective for restoring the gut microbiota, and the correlation between the brain and gut, which I know a lot of people have talked about in their own journal clubs, is even further confirmed. Now let's talk about what these authors set out to answer. These authors wanted to investigate whether FMT is effective at improving the clinical symptoms of Parkinson's disease. They wanted to determine whether the change in the gut microbiota composition directly causes these health improvements in patients with PD. And they wanted to figure out if FMT is a safe treatment for those with PD. And they administered fecal microbiota transplantation through these oral capsules, which you can see in this little photo right over here. Although I've kind of already covered it, I'll reiterate what Parkinson's disease is. It is a movement disorder of the nervous system that worsens over time. There are many things that make Parkinson's so difficult, but to manage. But it causes parts of the brain, nerve cells, and parts of the brain to weaken and eventually die. The most common area for the loss of these neurons is in an area near the base of the brain, and this area is known to produce dopamine. And dopamine is the chemical messenger in our bodies that transmits signals in the brain to conduct smooth movement. It has been shown that people with PD have lost about 60 to 80% of these dopamine producing cells by the time symptoms present themselves. And this is irreversible damage. So, as I stated right here, there's currently no cure for PD. There's only medications that people use to manage it. Now, there are tons of inspirations that I found for this study, and I'll go through about 5 of them. The first is that the communication system known as the gut brain axis has been found to provide insight on neurological disorders. The second is that the pathology, which is the study of the nature, causes, and mechanisms of a disease of PD, doesn't solely depend on the dopamine in the basal ganglia, which is that lower part of the brain that I just discussed previously. And this is honestly very interesting news in this article published by Dr. Kalia, because this means that PD is no longer solely associated with the loss of these dopamine regions in the brain, but it also involves other extensive regions of the nervous system. Um, and this is an issue because the current medications solely focus on these dopamine regions. So we might not be tackling this disease to the best of our ability right now. And then recent studies, as shown in right here in the Shen and the study done by Shen and others, show that the microbiota of gut microbiota of patients with PD um, is significantly different from that of healthy individuals, particularly in the area of the butyrate producing bacteria, which is related to anti inflammatory pathways. And these patients with PD have a relatively lower abundance of these bacteria. Now, as we can see right here, there was also a study done on murine models, which is just mice, and it revealed that the gut microbiota of mice with Parkinson's disease can induce motor impairments and reduce striatal neurotransmitters in healthy mice. So fecal microbiota transplantation was conducted on these mice and helped restore microbial balance, reduced fecal short chain fatty acids, and improved motor function within these mice. And this kind of gives us a good outlook that this might work on humans. So this led to preliminary clinical studies, which were conducted, I think, at first in 2020, which wasn't that long ago. And it was a relatively small study because it was a preliminary study. It was about 15 people. 10 received a colonic FMT, and 5 received a nasointestinal FMT. And we saw symptomatic improvement in these PD patients, and they had minimal adverse effects to the treatment, which um, kind of opened the doors to make larger studies. Which is why the study that I'm talking about in this journal club, we need it. These preliminary reports were only done on a small number of participants, so we need further research on a larger cohort to determine if it's a safe and effective treatment. Now, let's jump into the methodology behind this particular study. There were 101 subjects, all aged 30 to 85, with mild to moderate PD. Any patients with extremely serious PD symptoms or difficulty in communication were excluded. Patients were randomly assigned to be a part of the placebo or FMT group. There were 4 stool donors that were strictly screened and deemed healthy, and they provided the stool to make the FMT capsules. 16 FMT or placebo capsules were taken once a week by each subject on an empty stomach for 3 consecutive weeks. There was no donor recipient pairing that occurred. All patients received FMT from a random donor each time. These 16 FMT capsules were made out of 50 grams of donated stool. And the appearance of these FMT and placebo capsules was indistinguishable. So the patients didn't know what they were receiving. They were also administered at the hospital to really make sure that the patients were unaware of the content. And each subject maintained their PD medication regimen, and medical guidance did help them maintain a healthy diet and rest schedule. So, after the actual clinical study was conducted, the researchers conducted lots of analyses. They used, for microbiome analysis, they used 16S RNA gene sequencing. And this was to form a co occurrence network and understand the correlations among different genre of bacteria. And metagenomic libraries were prepared using the Illumina NovaSeq 6000 platform. Microbiome bioinformatics was performed using the QIIME2 software. Taxonomic composition was profiled using the Meta Phi and 3, and functional pathways were determined using the Human 3. Now, as for statistical analysis, relative abundance of each genus of bacteria was determined using the Spearman's correlation coefficient. Descriptive statistics were performed to demonstrate demographic features, health conditions, and clinic manifestations during each follow up. The GEE, which is the generalized estimating equation, um, these models were used for statistical analysis, and they basically are models that are used to show the differences in subjects' characteristics between the placebo and FMT groups after intervention. So let's jump into everyone's favorite part, which is the results of this study. This particular table really caught my attention, and it proves that FMT improves the PD associated symptoms in patients. Now, this looks like a ton of information, which it absolutely is, bunch of letters, bunch of numbers. But I'm just going to bring your attention to certain parts of this table. So first, let's kind of discuss some terms. The MDS-UPDRS stands for the Movement Disorder Society-sponsored revision of the Unified Parkinson's Disease Rating Scale. And this is a rating scale where people with Parkinson's and their clinicians sort of rate the symptoms, the symptoms that they're feeling, and it features a total score as well as a score, as well as scores from four sections. And they kind of just fill out a questionnaire. So part one right here are non-motor experiences of daily living, and you rank that. And then part two right here are motor experiences of daily living. Part three are motor examination, and part four is motor complications. In this table, you can see a total MDS UPDRS score right here, as well as parts 1, 2, and 3. And they are all performed at baseline, as well as follow ups at weeks 4, 8, and 12 post intervention. To explain this table as simple as possible, I would like to just bring your attention to the score column right here. As you can see, the participants in the FMT arm and the placebo arm, they do have very similar scores at the baseline of week 0. However, when we look down to the total score at week 12, we can see a significantly larger decrease in the MDS UPDRS score in the FMT arm. If it wasn't already clear, a lower MDS UPDRS score is considered better because higher scores indicate a greater severity of Parkinson's disease symptoms. So a lower score represents a milder condition. Essentially, a 0 would be considered normal. The results shown in this table indicate that the combination of conventional PD treatments along with FMT showed better improvements of symptoms. The placebo arm, they didn't receive FMT, but they did still follow their medication regimen, which is why you do see improvements, but obviously it's not as significant as the combination between them taking the medications and having FMT. So the table that I just previously showed had a ton of information on it. So this is a continuation of the table on the previous slide, but this is focused more on gastrointestinal symptoms. Because if you guys remember, I did say that there are motor and non-motor symptoms that people with Parkinson's disease experience. And so I wanted to focus on the gastrointestinal disorders and how this table shows that GI disorders in PD patients were improved by FMT. So the authors performed IBS, SSS, GSRS, and IBS QOL scales to assess whether participants benefited from the interventions in terms of GI disorders. Both arms did, show improvement, as you can see, starting at your baseline week 0 and jumping all the way to week 12. These are some significant improvements, but as you can see, the larger improvements are seen in the FMT arm, which is it's a very bright outlook. Because this is such a decreased severity that we're seeing right here, and you can't, like, I can only imagine how much better these patients must have been feeling. So these are some other really interesting results that I found in while looking at the study. These focus on how the gut microbiota composition in PD patients differs from that of healthy donors. First, let me bring your attention to um, right over here in panel A. This focuses on alpha diversity, faith in its faith's phylogenetic diversity, and FACE PD index measures the microbial phylogenetic diversity, which is also known as the evolutionary relatedness of a species in a sample. And as we can see here, donors have a significantly lower diversity compared to both PD groups, the placebo, and the FMT groups. As for panel B right here, we're still looking at alpha diversity, but this time we're looking at observed OTUs, which are operational taxonomic units, which basically represents species richness, how many unique species are present. Similar to panel A, the PD's patients in both the placebo and FMT group have significantly higher richness than donors, these healthy donors. Now in panel C, we're looking at beta diversity in the form of a PCOA plot, which is a principal coordinate analyses plot, which basically visualizes differences in microbial community composition. Each point on here represents an individual's gut microbiome, and ellipses show clustering patterns. For the donor group, we have the green here. For the placebo PD group, we have the orange here, and for the FMT PD group, we have the blue here. The placebo and FMT group largely overlap, as you can see with their two ellipses here, which kind of shows that FMT did not drastically shift microbiome composition here toward the donor profile. However, in some individuals in the FMT group here, we do see a slight move towards the donor cluster, suggesting partial microbiome changes post FMT. So basically, what these figures show is that PD patients do have a higher microbiome diversity compared to donors. Now, this figure right here is kind of a continuation of what I just went over on the last slide, that the gut microbiota composition in PD patients differs from healthy donors. This figure represents the relative abundance of different bacterial phyla and stool samples from the three groups. Right here we have the donor, right here we have the placebo PD group and the FMT PD group. And I'll jump into like an explanation of these groups. This is the placebo group basically are like the Parkinson's disease patients before FMT. This is the healthy donor group, and right here are the PD patients who received FMT. There are some key observations that I'd like to point out in this figure. That in the placebo group, there is a higher diversity of bacterial phyla, but there's a significant difference in the bacterial composition from the donor group, which we can see. In the placebo group, the relative abundance of the firmicutes, which is this darker blue right here, and bacteroidetes, which is the light blue right here, appears to be altered in comparison to the donors. So that kind of shows that they have initial different back to micro or gut gut microbiota compositions. Also, right here, there's a noticeable presence of proteobacteria in the placebo group, the brown right here, and verrucomicrobia, which is the red right here. And these two have been linked to gut dysbiosis in PD. Now, moving on to the after FMT group right here, the microbiota composition seems to shift towards a a pattern more similar to the donor group. Certain phyla, such as the firmicutes, right here, the darker blue, and the bacteroidetes, which is the light blue, appear to increase in abundance, which we can see kind of resembles the donor group, while the proteobacteria, the brown here, and the verrucomicrobia decrease. So since those two, the proteobacteria and the verrucomicrobia, are both linked to gut dysbiosis, seeing that they decrease after FMT is a very good sign, that it's working. And this suggests that a FMT may help restore gut microbiota balance in PD patients. Obviously, in the future, further analysis would need to be done to determine whether these microbiome changes from the placebo group to the FMT group correlate to symptom improvement in PD. But this is a very, very bright outlook because it's basically saying that potentially FMT can restore a healthier microbial community in PD patients, similar to that of a healthy donor. So I wanted to point out another big aspect of this study, which is that the FMT treatment didn't work for everybody in the FMT group. The researchers observed notable differences in patient responses in the FMT group. Some participants experienced significant symptom relief while others did not. So the FMT group was further divided into a responders subgroup and a non-responders subgroup for further analysis. Metagenomic analysis, which is kind of demonstrated by the panel E right here, revealed that certain butyrate producing bacteria from the Firmicutes phylum right here were significantly enriched in the FMTR group compared to the FMTNR group. Furthermore, the presence of these microbial species is positively correlated with improvements of gastrointestinal function and alleviation of Parkinson's disease symptoms. So in FMTR, we see more of this group, which is very promising. But it's unfortunate for those who didn't respond. But it's nice that the authors, made note of this and separated these two groups. Now, in panel A right here, we basically it shows the changes in the MDS UPDRS scores over 12 weeks between the FMT responders and the FMT non-responders. And significant improvements are seen in the FMT responders, which are the red, and compared to the non-responders blue, especially in the total scores. And this just suggests that FMT may alleviate motor symptoms in this subset of PD patients, which shows it as a promising therapeutic option. Now, panel B right here is just a study design diagram, which kind of just shows how the FMT group kind of diverges into two subgroups. And C right here is just an estimate of the microbial richness, and shows that there's really no huge significant difference in the richness between the two groups. And it suggests that the overall microbial richness may not be a key factor in determining FMT response, and other microbiome changes may be possible. Instead, maybe looking at specific bacterial strains or function changes that in the microbiome that may be responsible for symptom improvement. And D right here is kind of what we saw previously, the PCOA axes and the differences. And it just kind of shows that between the FMT group, FMTR group, and the FMTNR group. As for the discussion of basically everything that I've just covered, let's jump into what we know now that we didn't know before. Basically, FMT via oral administration capsules is a much more accessible and acceptable preparation of treatment instead of conventional endoscopic routes, which require advanced endoscopists and equipment, which can be very expensive and time-consuming. We also know now that FMT significantly improves the effect of conventional PD treatment. And we also now know that FMT is effective in improving these non motor PD symptoms like the gastrointestinal issues. Now, broader implications is that patients now have access to FMT at home. If they're taking oral capsules, they can basically do that anywhere, which is great, and means that more people will be able to benefit from this treatment, and have access to better symptom management in combination with their normal medications. And it also this study also shows or gives us further confirmation that the gut microbiota is directly connected to the central nervous system. What do we still not know? Um, we still don't know, how effective this will be in the long run, because we're only in phase 2 of trials, and the the researchers only didn't only went up to 12 weeks following up with these patients. Um, the research on a cohort of thousands would be next for FDA approval. So obviously, this isn't an FDA approved way of treatment yet. This is something that I figured I'd present along with the information that I've already discussed. So you all know that no study is perfect, despite the promising results that this particular study showed. There are still limitations of this study, that being its small sample size. It was only 100 people, Um, and another big thing is that investigators did not perform allocation concealment, um, which basically, a larger cohort with a double or triple blind design, um, on improving the effective PD medication is still needed to further explore its effectiveness. And like I said previously, the follow up period was relatively short, so we're not really sure of long term effectiveness. To wrap up, let's finish off with some conclusions that can be drawn from this study. FMT has been shown to improve the efficacy of current PD medication symptom alleviation. FMT capsules is a safe practice with no adverse effects on patients, which is great. We didn't see any adverse effects throughout this study. The gut microbiota composition of individuals with PD and healthy individuals differs, which we saw from all the figures that I discussed earlier. And this can be, remediated slightly with FMT. And dietary guidance can also contribute to the improvement of PD related symptoms. This isn't really something that I have addressed in this presentation yet, but when these individuals are being studied on, they were put on a very strict diet by their clinicians. And this diet consisted of limited protein and high fiber consumption, which also could have helped in altering their gut microbiota, and could have definitely contributed to their improvement. I know this was a subject that was discussed by several other journal club presentations, especially looking at a ketogenic diet, and this can also be something that can be further researched in the future. Finally, I just wanted to present 5 questions to you all, so you guys can discuss and give me your opinions. I really enjoyed sharing this topic with all of you, and I really hope you learned something and enjoyed. And I'm excited to read your comments and get to talk to you guys and interact with you guys. So, thank you so much for watching. This has been extremely fun and promising. And hopefully, one day we can really help manage people's Parkinson's disease. All right, thank you.